Alright, so we're making some real progress here. Let's go ahead and run this. So I have compute shaders figured out. Right now this is just kind of a test thing. I've got the sort of front and back buffer, sort of, you can think about it that way. Basically there's a, I'm calling them current and previous, and they're switched between, first thing, I have compute shaders working. This is the basic format of the compute shader. Is you have the current content, or the previous content of the block. That's the image data. You have a previous value of the mask. Then there's current and current mask. So basically, this isn't final. This is just kind of putting it at the center with this distance here. So basically, you're doing an image load from the mask at the location specified by the invocation ID. So I found out that it maps 0 to 255 to the range of 0 to 1. I was trying to use integers here. It may be valid to switch to an integer texture, but look at that in the future. So right now it's just looking to see if you're within some range of distance from the from this center point, you call it, to the location of the current cell. Then if it's not masked based on the read that you did here, you're gonna write image data to the thing. So initially I'm initializing everything, the data for the which one is that? That starts as previous. The data for the previous one starts with a green value. It's non-zero, and the one that starts with current, or the one that starts as current, is red value. Then the masks, they're inverted. So let me just go ahead and put that way. Right, so they're either masked or not masked. I can't do like a 1-bit texture. It would be smaller, but that's not really something that's supported. It's loaded as an just a single channel texture, and they're 8-bit values. So initially you've got your previous image data in 0, and that's based on this. That's the binding point that I picked for each one. So 0, 1, 2, 3. Yeah, 0, 1, 2, 3. You get the mask values in 2 and 3. So just for right now, I have this here. You draw a sphere, swap the blocks. You draw the sphere, swap the blocks. So swapping the blocks is basically saying, alright, if current is in 1, change that to 0, and change previous to 1. And similarly, if it's not, then you do the opposite operation. This draw sphere invokes compute shaders for every cell. These layout qualifiers establish the workgroup size, so it's 8 by 8 by 8. The reason that you have those that way is it has to do with how the work groups are launched on the actual GPU. If it were 1 by 1 by 1, you're not making use of the parallelism as much, like not nearly as much. So getting the work group size here is 8 by 8 by 8 is um, 64 times 8, so that'd be 2 to the ninth is 512, I want to say. In any event, you set the values of where everything should be, and then this dimension, it's a thing that's defined in the includes thing here. So I'm trying to make this so that I can change the dimensions on that block just by changing this one number. So here, because that work group size is 8 on each dimension, dividing that dimension by 8. And this ensures synchronization of, make sure that that all those writes are going to finish before you get, before anything else happens. So, this is really pretty amazing stuff with the compute shaders. It was a lot easier to set up than I thought it would be. It really is even simpler than regular shaders to set up because and I repurposed my my shader compilation code from before. Just took out all the references to the fragment shader, then changed the names to match. I'll look at that in a second here. Whatever. We'll just take a look at it now. It's taking a minute. So, yeah, I've got this shader class. I just went ahead and added a C shader class, and it's all the same stuff to read from a file, and then I can get the program out. It's just a public member variable. So here we've got a sphere drawn with the masks value. Like I say, red is it's in 1. We swapped twice, so right, red is current, right? Red is initially current. And then green is initially previous. So you see they're the inverse of one another. One draws where the other one doesn't draw. The other one obviously is the opposite. And that has to do with how those mask textures are populated. And I can just swap between them because it's well, I just have it set up to do that. But yeah, so the next step is going to be adding some uniform variables to my compute shader. Stuff like uniform vec3, location, uniform float, radius. Color. So these will then play into what actually gets drawn. Right now it's just, bullshit so that I can see what's going on. But yeah, pretty exciting to have compute shaders working, and basically what I'm going to do is I'm going to have a different shader file then written for each of the operations I'm going to do, and each one is going to have a function associated with it, like draw sphere does here. and it's going to go through and do these different operations. So it's come together, and we're making some big steps. So I'll have more relatively soon.